and g of x. So if this question were on your diploma, you would just be given the graphs. You wouldn't be given this table of values to work with. This is something that you would have to create on your own. And then the image, because it's multiple choice, would be image A, B, C, or D, and you'd have to choose the correct graph. Okay, let's take a look. F of x is given on the left, g of x is given on the right. What you want to do in this question is write out the x coordinates, and f of x and g of x stand for the y coordinates on the given graphs. Okay, so maybe if we take a look at the graph, the furthest left point is when x is at 0, so let's start at 0. Okay, and that same thing occurs on graph G, x starts at 0. So we can write out x at 0, 1, 2, 3, and 4. On graph F, f of 0 is 2. Okay, so we're plugging in 0 for this x. F of 0 is when y is 2. Okay, f of 1 is when y is at 3. F of 2 is when y is at 4. F of 3 also at 4. And f of 4 also at 4. How are we doing so far? Okay, now we're going to look at g of x. G of 0 is at 0. Okay, the y-coordinate for g of 1 is at 1. The y-coordinate for g of 2 is at 2. The y-coordinate for g of 3 is at 1. And the y-coordinate for g of 4 is back at 0. So now that we've labeled the y-coordinates for f of x, the y-coordinates for g of x, we just need to add f of x plus g of x for that given x value. Okay, so if x is 0, f of 0 plus g of 0 is 2 plus 0, we get 2. Okay, next one, 3 plus 1 is 4. 4 plus 2, 6. 4 plus 1 is 5. And lastly, 4 plus 0 is 4. So we're just plotting these points now, and if you want to write them beside, you can. First one is 0, 2, and we have 1, 4, 2, 6, 3, 5, and 4, 4. Okay, so on your graph, just start plotting those. 0, 2, 1, 4, 2, 6, 3, 5, and 4, 4. So on your multiple choice, if you saw a graph that looks like this, then you would pick that one. Okay, so that first example, we just looked at the sum of two functions, but just keep in mind that table of values could have been f of x minus g of x, or f of x times g of x, or divided. Okay, the next example, you're given two equations, and you have to perform the operation as shown. Okay, so in this case, we're looking at a quotient. We have f of x divided by g of x. So that one's pretty straightforward. You just sub in the graphs into the equation. Okay, h of x equals f of x divided by g of x. Well, what was f of x? It was x plus 7. And g of x was x minus 3. So in the end, h of x is equal to x plus 7 divided by x minus 3. Now it doesn't ask for domain and range, but it doesn't hurt to talk about this. This is dealt with in the rational functions unit, but we can just talk about it now. For domain, do I have any restrictions on this graph? What's that, Troy? Good. We look at our denominator. We can never divide by 0, so x cannot equal 3. Everything else will be real numbers.
Yeah.
Okay, now I want you to take a look at the degree of the numerator and the denominator, same degree. So that means the restriction, or the vertical asymptote, will be 1 over 1. So in other words, y cannot equal 1. and all the other values will be real numbers. Just to give you a little visual on that, this is how the graph will look. Okay, what do we call this? What kind of asymptote? Vertical. And our vertical asymptote occurs at the non-permissible value, x equals 3. Okay, and the horizontal asymptote occurs at y equals 1. So compositions, you can see compositions in a few different notations, which is our next question. Just keep in mind you can see f of g of x as a composition, or this is the other notation, f of g of x, where g of x is inside the bracket. Okay, so given f of x equals 3x minus 1 and g of x is x squared plus 3, we have to figure out the value of f of g of 2. Okay, so first what you want to do is evaluate what is g of 2. Okay, well, here's g of x. I can just do this above if you want, little side work. Instead of x, I'm replacing the x with a 2. So what's this x replaced with? A 2. So we have 2 squared plus 3. Okay, I'm also going to put that over here as well, just so you can see it inside the brackets. So we've replaced g of 2 with 2 to the power of 2 plus 3. So 4 plus 3, we get 7. And next up, we need to evaluate f of 7. Well, f of x is 3x minus 1. So if I replace that x with a 7, I'm going to get 3 times 7 minus 1. Okay, so 3 times 7 minus 1, that's 21 minus 1, I get 20. Now the next one I might just talk about. If you had to figure out f of g of 2 using the graphs, what you would first do is look at the graph of g, and you figure out, okay, when x is equal to 2, what's the y-coordinate? Just like we did in the first question of this. Okay, and then whatever that is, you're going to plug into f of x. Okay, did you guys want me to go through that a little slower? We can look at the actual... Yeah? Okay. So g of x is equal to x squared plus 3. So what you could do is graph that if you wanted to. And you'll get a parabola. Okay, where the y-intercept is up at 3. So what you need to figure out is what is the y value when x equals 2. This is g of x.
Just for like table and your calculator?
Yep, so you can go second graph and look at the table of values, and then you'll get that y-coordinate for g of x. Okay, just verify it for me. I mean, never mind, we already did it algebraically, right? When we subbed in 2, we got 7. Okay, so that will be when y is at 7. So now we're evaluating what is f of 7. So then you look at the line for f of x equals 3x minus 1. Okay, positive slope. You'd have your line here. And that'd be positive 1 over 3 is your x-intercept. Okay, now when x is at 7, what's your y-coordinate? I obviously didn't draw this line very accurate, but it should be at 20. Okay, and again, you can put that into your calculator and go second graph, look at the table of values, and figure out what is y equal when x is 7. Question?
Aren't you supposed to use a graph to do that?
So this was part of this question here, I believe. Let me just see how I organized it. No, I didn't want to use those graphs. Okay, we'll use these graphs. We'll practice it twice. So in that example we just talked about, the graphs were not given. In this example, the graphs are given. Okay, so we again are going to figure out what is f of g of 2. So first we're going to look at the graph of g of x. Our goal is to figure out what is g of 2. So what does 2 represent, our x or our y? X. So where x is 2, we're going to go up and y is at 2. Okay, so g of 2 equals 2. So we have f of g of 2 equals f of what now? 2, because g of 2 equals 2. So we're going to go to the graph of f of x, and we're going to find where does x equal 2, right here, go up to the graph, and y equals 4. Okay, so the solution to this would be 4. So when the graphs are given, fairly straightforward. When they're not given, just use your table of values on your calculator. So the last few examples were about evaluating compositions. Now we need to find the graphs or the equations of compositions. Okay, so given f of x is the square root of x plus 1 and g of x is equal to 2x, we're going to find the equation for f of g of x. Okay, so in other words, we're plugging g of x into the x on f of x. So f of g of x will equal, what's g of x? 2x. So this 2x is going to replace every x in f of x. In other words, we get the square root of 2x plus 1. And there's no further simplifications that we can do, so we can just leave it at that. Okay, I'm just going to add one. What if h of x equals x squared plus 3? Okay, and you're asked to find h of f of g of x. Okay, have we already figured out what f of g of x is? Yes, right here. Okay, so we're now going to have h of the square root of 2x plus 1. And we just need to sub in the square root of 2x plus 1 now into this x. Okay, so we're going to get the square root of 2x plus 1, square that, and then add the 3. Can that be simplified? Yeah, the square root and the square are going to eliminate each other. So we get 2x plus 1 plus the 3, and then just add the 1 and the 3. So 2x plus 4.
You don't solve for x.
No, this is just finding the equation of the composition. Okay, just so you guys are aware, this would be a basic composition, and on your diploma, this would be a standard of excellence question, where you have 2 compositions. Okay, so anytime there's, pardon?
What's the difference?
Standard of excellence questions are more advanced, so they're considered more difficult. Okay, so this would be the easy version of compositions. One extra step, like anytime there's extra steps involved, typically that's titled a standard of excellence.
So basically you get like that, but you just started with that, like finding f of g of x first, and
Yeah.
then find h of.
Yeah, so if you get a question like this, I would almost just hide that h for a second. Deal with f of g of x first, and then plug it in. Okay? So on the next one, given the equations of 2 functions, you're going to have to sketch a composition. Okay, so this one's pretty similar to the one we just did. The only difference is now you're just going to have to graph it. Okay, in the last one, we ended up with, what was it, 2x plus 4? Are you guys capable of putting that in your calculator and then graphing it? I think so. Okay, so that's going to be the same thing here. You're just finding a composition, and then finally you'd have to graph it. For practice, let's just do the composition here. So I have f of g of x. Okay, my g of x is x minus 1. So I'm going to sub that into the x value for f of x. Okay, f of x is equal to x squared plus 3. So instead of x squared, what will I have? X minus 1 squared plus 3. Now if you wanted, you could graph that right away. Or you can expand it x squared minus 2x plus 1 plus 3. You get x squared minus 2x plus 4. So you could graph at this point, or you could graph at this point. And then from there, use your table of values if you want some specific points. Okay? Or you could sub in values of x to get the output values of y. Okay, the vertex will be 1, 3. So I know it's going to be somewhere here. And then you just make sure you're graphing the accurate points. Keep in mind diploma questions are going to be multiple choice. So remember from grade 11, I can find my vertex from this form. Okay, 1, 3 will be my vertex. So in a way, this was more helpful than this.